And here we go again, Geometry Chapter 4-7, Congruence Transformations. A transformation is an operation that maps an original geometric figure onto a new figure. Transformation can change the position, size, or shape of a figure. Now, the pre-image is the original shape, original figure, and the image is the new figure after the transformation. Should already be familiar with transformations. Today, more specifically, we're looking at congruence transformations. Now, a transformation can be noted using an arrow like this. That means this triangle, the pre-image, moved this way. The transformation statement here, ABC is congruent to XYZ, tells us that A is mapped to X, B is mapped to Y, and C is mapped to Z. The order matters in which you write this. Okay, so notice which ones are the corresponding corners. Those have to be in the corresponding place. A congruence transformation, also known as a rigid transformation or isometry, is where the position of the image may differ from that of the pre-image, but they're still congruent. So the shapes haven't changed. One isn't larger or smaller than the other. They are still congruent. So there are three different types. We have reflections. The reflection is kind of like it's mirrored across something. So this here would be a reflection, okay, across a line. A translation is where it's moved from where it is originally, but it doesn't rotate at all. It's still pointing in the same direction. So that would be a translation here. And then a rotation or turn is around a fixed point. So something like this. That would be a 90-degree rotation around that point. All right. So identify the type of transformation shown. Notice it's moving, it's rotating about that point right there, about the origin. So this is a rotation. Looking at this transformation right here, notice these points both point inwards. So this is a reflection. The points that are closest to the y-axis are closest on the other side. And then looking at this right here, we're moving directly, but we're not rotating, so this is a translation. Every point, every vertex is moved 3 units left and 3 units up. Now, if we look at this, here we have a little girl playing a game. She has a weight attached to her foot, and it's going around and around. She skips over this ball right here, and this is a rotation. In this case, the center of rotation is her ankle. Now, congruence after transformation. To check whether after transformation it's still congruent, we can use the distance formula. So here we're given the coordinates of 2 triangles. We graph the original figure and its image. Okay, so there's our original figure and its image. And now we are to identify the transformation, what happened here, and whether it's a congruence. So triangle XYZ is reflected across the x-axis, and we can use the distance formula to check for congruence. So remember the distance formula, we have the change in the x squared plus the change in the y. Remember, this is derived from the Pythagorean theorem, a squared plus b squared equals c squared, where a to b we need to figure out using the coordinates in this case. So this line right here is congruent to xz. Now we'll have to check the others. Check congruency for BC. Use those coordinates in the distance formula, and then the same thing for the corresponding side here. We can see they're both 29. Same thing on the last side. Notice once we've checked them, they are both the same length. So since all three sides are congruent, this is a congruence translation by side, side, side. And there you have it, ladies and gentlemen. Remember to like and subscribe and hit that notification bell.